In this video, we're going to talk about another identity called the sum and difference identities of cosine. So what are these sum and difference identities? Okay, there are two. So when we take a look at our formula, it will say the cosine. So for sum, we will add two degrees or two radians together, and I can separate them out into cosine of A times the cosine of B minus the sine of A sine of B. For the difference, it'll be cosine of A minus B, and we will say cosine of A, cosine of B, then it'll be opposite sign, so plus sine of A, sine of B. So again, things to kind of be paying attention to is this A and this A are exactly the same, right? And my B and my B are going to be exactly the same. Now, how can you remember this? We can sing it to the tune of Happy Birthday, right? So if you remember that tune, right? Basically in words, we are going to sing this, right? So change the sign. So happy birthday to you, happy birthday to you, right? So we can say cosine, cosine, sine, sine, change the sign, cosine, cosine, sine, sine, change the sign, cosine, cosine, sine, sine, cosine, cosine, sine, sine, change the sign. So again, whatever value we see in between our two values, it will be the opposite in between our two sines and cosines. So let's try a couple examples. So cosine of 15 degrees. So 15 degrees is not on our unit circle, so this is when we would use this identity. So there are a bunch of different numbers that can add up to 15 degrees, but the two numbers that I thought of right away are 45 minus 30. Okay, so again, 45 kind of becomes my A value, 30 becomes my B value. So this becomes the cosine of 45 times the cosine of 30, opposite sign, so plus, and then sine of 45, and then sine of 30. All of these numbers are on our unit circle. So then we can cosine of 45, so this will be a root 2 over 2, and this will be a root 3 over 2. This will also be root 2 over 2, and this will be 1/2, right? So I can multiply my radicals together to give me 6 over 4 plus root 2 over 4. They are the same, so that means that the cosine of 15 degrees is root 6 plus root 2 all over 4. So depending on which values you decide to use, right, we could have said 60 minus 45, right, we are going to get a very different answer, right? Or the values might be switched, okay? Root 6 might not be first, root 2 might be first. We can also see this in terms of radians. So let's try a second example. So cosine of 5 pi over 12. Now you might be thinking, oh, 5 pi over 12. Again, that's not on our unit circle. I can always change it to a degree if I really wanted to. Or if I remember, right, pi over 3, this will be the same thing as saying 4 pi over 12. I could also say pi over 4 is the same thing as saying 3 pi over 12. And then my last one, pi over 6, is the same as 2 pi over 12. The likelihood that you are going to use maybe a pi over 2 is slim, right? Because that would require, if you think about how to get 5, I'd have to say 6 minus 1, and 1 pi over 12 is just not on a unit circle. So chances are you're probably going to use your, again, 30, 60, or 45 degrees. Okay? So when I think of 5 pi over 12, right, the two numbers that pop in are going to be 3 pi over 12 plus 2 pi over 12. Okay, and at any time you can always simplify it. So again, if I wanted to simplify it right away to pi over 4 and pi over 6, that's perfectly fine. So this is going to give me the cosine of pi over 4, the cosine of pi over 6, opposite sign, minus, and then same thing with sines. And then I use my unit circle, and this is going to leave me with root 2 over 2. pi over 6 is root 3 over 2. Again, minus, this will be a root 2 over 2. And then this will be the 1/2. This is again going to give me root 6 over 4, root 2 over 4. So my lovely cosine of 5 pi over 12 will be root 6 minus root 2 all over 4. That's our answer. You're going to notice that these values are very similar to each other in terms of what we're going to get, right? So you're going to have a 4 in your denominator, you're going to have a root 6, and you're going to have a root 2 of some sort, okay? All right, if you want to try a couple practice problems on your own, so this is just extra practice, go right ahead. Try the cosine of 105 degrees and try the cosine of 7 pi over 12. Okay, so if you tried cosine of 105, what we could have gotten is we could have gotten root 2 minus root 6 all over 4. So if you got that right, there's no need to watch this video. You can fast forward to the next one. But if you didn't get that, these are the numbers I chose. I chose cosine of 60 plus 45. So again, cosine of 60, cosine of 45, minus sine of 60, and then the sine of 45. Okay, so this will give me 1/2 root 2 over 2, root 3 over 2, and root 2 over 2. So that's where I get the root 2 over 4 and the root 6 over 4. Again, depending on what we said, we could have said 45 and 60 switched. You could have picked a couple other numbers to add up to 105. Again, whatever you chose, make sure that it was correct from our unit circle. For cosine of 7 pi over 12, it actually was exactly the same answer. So if you got root 2 minus root 6, again, you can fast forward the video. But if you didn't, I put the numbers 3 pi over 12 plus 4 pi over 12 to give me 7 pi. And again, 3 pi over 12 is the same thing as pi over 4, and 4 pi over 12 is the same thing as pi over 3. So this will be the cosine pi over 4, cosine pi over 3, 3 minus sine of pi over 4 times the sine of pi over 3. All right, hold on, I'm going to rewrite that 3 and sine. So sine and then 3. Okay, pi over 4, again, that's 45 degrees. So that's still root 2 over 2. And this pi over 3 is at 6 degrees. It's still 1/2. And again, root 2 over 2 and root 3 over 2. So again, I'm still going to get the root 2 over 4 minus root 6 over 4. Okay, so what happens if I write a different problem? So I write something like this. So I just say simplify this problem. And it says the cosine of 87 degrees, cosine of 93 degrees, minus the sine of 87 degrees, sine of 93 degrees. So again, you can always pause this video, try it out on your own. What you should notice, right, is that 87 and 87 are my first values in this problem. And I notice that 93 and 93 are my second values. So it's safe to say this is a this is a cosine, either sum and difference. So I'm going to do something with the 87 and the 93. But I see an opposite, I see a subtraction, so I want to include the opposite sign. So I'm going to include an addition sign. So I'm going to go ahead and I'm going to add those numbers together, and I'm going to get 180. Now 180 is on my unit circle, 87 and 93 were not, so cosine of 180 purely is -1. So we can simplify it down to those values. All right, so what else can we do, right? So what happens if we have a problem that looks like this? So let's say we're going to find the cosine of a plus b, and we will find the cosine of a minus b, and we are given this information. So we'll call this number 1. So the sine of a is 2/3. The sine of b is -1/3. A is going to be in quadrant number 2, and B is going to be in quadrant number 4. Okay, so this might be confusing because you're like, ooh, what could A be? We are not finding what A is. We are not finding what B is. We are finding what happens when I add those numbers together. So the first thing that I'm going to do is I'm going to expand my identity. So cosine of A, cosine of B, minus sine of A, sine of B. Okay, so I don't have a cosine of A, so I'm going to leave that blank. I don't have a cosine of B, but I do know that sine of A is 2/3 and sine of B is 1/3. So I need to figure out, okay, what could I do? Okay, well, I'm given some information that things are in specific quadrants. So I recall that sine of theta is made up of y over r. Cosine of theta is made up of x over r. So let's find the a first. So again, knowing that sine of A was 2/3, I know that 2 is my y, so 2 squared, and I don't know my x, and then I know my r value is 3 squared. So again, I'm using this lovely formula. So I can say 4 plus x squared is equal to 9, x squared is equal to 5, x is equal to the plus or minus root 5. Now, here's where this information comes. We're in quadrant number 2, right? Quadrant number 2, right here, I know that my x's are negative and my y's are positive, so that means my cosine of A has to be a negative root 5. It's going to be the same value as the denominator, so this will just be a root 5 over 3. And I could do the same thing to find my B value. So I'll do B in a different color. So again, I'm given that the sine of B is negative 1/3. So negative 1 squared plus x squared is equal to 3 squared. So 1 plus x squared is equal to 9. This gives me 8. Now, I can simplify the radical of 8, right? That does simplify down into root 4 and root 2. So that does give us 2 root 2. Again, I'm in quadrant number 4, so I'm down here, where my x is positive this time and my y is negative. Again, I'm finding my cosine, so that means my x will stay positive. So this becomes a 2 root 2 over 3. We go ahead, we combine our like terms. So radical and radical, this will leave us with a root 10 over 9, and then negative and a negative will turn out to be a positive 2 over 9. So this is our A plus B. Now the great thing about this is once you find your A plus B, your A minus B is just the opposite. So negative 2 root 10 minus 2, and again, all over 9. Because the only difference is when we're subtracting, we're going to say cosine of A, cosine of B. This time there will be plus, and then, oops, I started writing out the values. Sine of A, sine of B. So again, I found all this information already, so there's no need to go ahead and reinvent the wheel again. Plus, again, 2/3 and negative third. Again, positive, positive, negative, that's going to be a negative. And we get our value. Okay, let's try the same thing, but with a different problem. So again, we're going to find the cosine of A plus B, and we'll find the cosine of A minus B, given this information. So this will be number 2. So this time our cosine of A is root 2 over 4, and our sine of B is negative root 5 over 6. A and B are going to be in quadrant number 4. So go ahead, try pausing the video and working this problem out right now. All right, so if we paused the video, again, the first thing I like to do is write out my problem. And again, I'm going to choose one of my values. I chose the plus sign. Again, I was given the cosine of A, so I'm going to put that value in. I was not given the cosine of B. Sine of A I was not given, but sine of B I was. So negative root 5 all over 6. Okay, so for my A value, right, again, I'm going to set up with my equation. X squared plus y squared is equal to r squared, using my cosine of A is equal to root 2 over 4. Okay, so we plug in, so root 2 squared plus y squared is equal to 4 squared. So this becomes 2, and then this becomes 16. Y squared is 14, so y is going to be plus or minus the radical of 14. Again, I'm in quadrant number 4. I need sine, so sine of a will actually be the negative root 14 over 4. So negative root 14 all over 4. And then I'm going to do the same thing for b. So I will have x squared plus negative root 5 squared is equal to 6 squared. Now when you square both the radical and the negative, that will just turn to a positive 5, and then 36. This will give you 31, so plus or minus 31. Again, I'm in quadrant number 4, and x is positive in quadrant number 4. Oops, let's put cosine of b, and so root 31 all over, 6. Same denominator, so root 31 all over 6. So all we have to do is multiply these bad boys together. So we are going to get root 32 all over 24, negative, negative, and a negative, so this will be minus, and this should be 72 all over 24, which means if I want the cosine of a minus b, it'll be exactly the same thing, except my signs are opposite. Okay, so the last thing that we are going to address is verifying. So we want to verify the identity. So let's start with our first one. So cosine of 2x is equal to 1 minus 2 sine squared of x. Okay, so what looks more complicated is that on the left-hand side, we see a 2 in front of the x. So this side, oops, let's undo that. Sorry. So this side looks a little bit more complicated. So using what we've kind of accomplished today, I want to expand my 2x. So the first thing that I notice is that I can expand it using x plus x. Once it's an x plus x, then it takes us back to our identity. So this will be the cosine of x times the cosine of x, and then opposite sign, and then sine of x, sine of x. When I'm multiplying the same trig twice, I get cosine squared of x, and then over here will be minus sine squared of x, well, equal sign. Okay, always ask yourself, where are you going? So on the other side, I see I just have sines, so I gotta get rid of my cosine squared. So I know that I can replace that with a 1 minus sine squared of x, right? Minus sine squared of x. I don't necessarily need my parentheses because there's nothing to distribute, so I can kind of drop them. And notice that on the left-hand side, I have 2 sine squared x's. So it becomes 1 minus 2 sine squared x, and the right side and the left side are equal to each other. All right, let's do another one. Okay, what about this one? Cosine of pi over 2 minus your alpha is equal to sine of alpha. Okay, so again, what side looks a little bit more complicated? Well, for me, the complicated side has a subtraction sign in it. So that would be the more complicated side. So again, I see that there's a subtraction. So again, the first thing that pops into my head is my sum and difference. So it becomes the cosine of pi over 2 times the cosine of alpha. Change my sign, so plus sine of pi over 2 sine of alpha. Well, the great thing about cosine of pi over 2 is I know that that gives me 0. And then the sine of pi over 2 is just 1. Oops, let me change row alpha first. So this becomes the sine of alpha. So 0 times the cosine alpha goes away, 1 times sine. This will just be sine of alpha. And guess what? Sine of alpha. So just FYI, this is something known as a double angle, which we'll talk about later. And this is an example of something we talked about last semester called co-function identities, right? So proving that these two are equal to each other. And that is 5.3.